Having diversity of models on Bittensor is very important. Decentralized science models that do research and apply learnings from research to real-world applications is an important application that should be hosted on Bittensor.
We face an existential level threat from climate change and pollution, and in that space between, there is trillions of dollars and billions of lives on the line for what we're facing over our lifetimes, the next 50 years. There's so much money in solving these problems. It's just very hard to capture.
Amateur astronomers do make meaningful contributions and meaningful discoveries. The same thing is possible and happens here with geospatial data. If we can develop a platform and tools where the average amateur enthusiast or researcher that doesn't have access to a ton of funding can use the tools and data and analysis pipelines that we provide and can contribute to understanding how climate change impacts the world, then that is a net positive on the world. Climate research in general is super important because, we all live on this planet. This is the only planet we know of that has life on it.
We have seen in our lifetime these Aurora borealises are coming further and further, closer to the equator, when typically in the past they stay towards the poles. A reason for that is potential in our atmosphere thinning. There's pollution in our atmosphere. There's a lot of ways to incorporate just a simple Aurora forecasting task into something broader, like how thin is our atmosphere, or what is going on in the ionosphere? Are there holes in our atmosphere, and where are they? What are the effects of pollution on the atmosphere? There's a lot of routes we could go.
Why should people care about predicting soil moisture or DST? One, the data, the predictions and data those tasks in themselves generate is already valuable for research, in the sense that DST is very important for monitoring solar weather, and especially if there's a coronal mass ejection or, elevated solar winds, that can directly impact GPS satellites, sensitive electronic equipment on the ground. The world is only being more reliant on that kind of technology. That sets us up to build a framework where we can make a warning system or a classification system that can signal alarms in advance to say, hey, maybe you should prepare because there's going to be increased solar wind that might impact your satellites or impact, the electrical grid. For soil moisture, we could either go the more agricultural route. We can go more disaster risk route in terms of predicting floods, predicting landslides. So smart to pick those tasks because it doesn't funnel us into one direction. We can open up to a lot of directions.
Welcome to the Ventura Labs podcast. Today, we're joined by Stephen, Noah, and Gabriel, creators of Gaia, a decentralized platform bridging the gap in geospatial machine learning. They're building a comprehensive system for analyzing and utilizing geospatial data. With a focus on soil moisture and geomagnetic predictions, Gaia aims to democratize environmental data, empowering researchers and industries to make data-driven decisions to drive innovation. And now, back to Stephen, Noah, and Gabriel with the 21st Ventura Labs podcast.
What inspired the creation of Gaia, your guys' subnet?
Sure. Well, I guess it's a long story for probably all of us, so I'll try to keep it short. But when I started in Bittensor, I had come from a geospatial research background. We were working on a project that was doing it in a lot of ways. It was the inspiration for Gaia. Basically, what we were doing was trying to index a lot of geospatial sources and then have an LLM be able to retrieve them so that it was essentially a chatbot for understanding geospatial data, targeted towards researchers, policymakers, stuff like that. So in that process, I started in Bittensor, and then I was thinking about just the gap that I saw in Bittensor. There weren't any subnets focused on geospatial machine learning. And it's kind of it's a field that's not as focused on as just pure large language models, obviously, but it's very extensive. There are so many ways you can go with it. And it's really exciting to me. So then also when Stephen and Gabby joined, we all got excited about it because both of you guys have backgrounds in geospatial-ish areas as well. So that's kind of the inspiration behind wanting to go this direction. And then it was a lot of brainstorming and just, like calls where we just basically were yapping away for hours, like talking about what we could potentially do. And that's where we started. Do you want to add anything, Stephen or Gabby?
Yeah, I think some sort of decentralized science is really what got us all excited about it. And I do think like having diversity of models on Bittensor is very important. And I think that decentralized science models that do research and apply learnings from research to real world applications is an important application that should be hosted on Bittensor. And I think a lot of Bittensor's tools helps us build out this geospatial platform where we otherwise wouldn't, with limitations to compute power or lack of resources, i.e. we don't have 256 miners developing models and helping us find what's the most optimal model for the specific problem we're trying to solve.
Anything you would add to that?
Yeah. I mean, just to kind of go on to like what inspired the creation of Gaia was really like I came into this when Noah and Stephen had already kind of formed the idea. And so when I jumped onto it, I already had the inspiration and creativity of the science background, like going from my previous work in the scientific community. So it was really great to just jump on and kind of help with that creation. But yeah, that's kind of my addition.
Yeah. So how would you guys define each of y'all's roles in what you're doing with Gaia? And simply stated, what would you say Gaia is? What is the purpose of Gaia? What is Gaia doing?
Sure. So I think as far as roles go, we definitely kind of all tackle problems together. Stephen and Gabby both have their specific backgrounds and have applied their knowledge to tasks from their backgrounds. We felt like that was the strongest place to start from, is just let's not reinvent the wheel. Let's just take what we know and start there. So I would say, like, as far as roles go, I have not a lot, but I have experience in subnet development now. I've been doing it for almost a year. So I kind of started off with like the broad sketches of the subnet itself and like designing an incentive mechanism and all the things that are crucial to operating in the Bittensor framework. And then Stephen and Gabby both took their individual expertise and focused on developing our first tasks. But at this point, it's kind of like we're all working together on, hey, what's our next thing? What's our next feature? What's our current problem? What do we need to solve now? So it's very much a shared project between us at this point. And Stephen, Gabby, I don't know if you want to add anything to that.
Yeah. I mean, I was just going to say, I'm just a developer, and I let Noah get in trouble, if if anything happened. No, I do. I think it is very shared, and we all take responsibility for this baby that we've created, and I think we're all really proud of it.
And then, Stephen, how would you define your role in Gaia?
Yeah, it's a good question. I think, like they both said, we all try to split our expertise. I think it's more efficient if we apply our specific unique backgrounds and skill sets in different directions to help build it out fully. I mostly worked on the soil moisture task. I applied a lot of knowledge I had from an astrophysics background in terms of data processing and analysis. And I also make models as well. But we all help with problems that come up or new features we need to add to the subnet as a whole.
And what is y'all's background in science related fields that helps contribute to the work you're doing at Gaia? Because you all said you have previous history working in this space.
Yeah. So I have a degree in computer science, and that was kind of what I ended up on, but I spent a long time in school trying to figure out what I wanted to do. So I like to call it an extended liberal arts education, but I've always gravitated towards like earth science. Like geology was one of my favorite science classes and subjects. And I've always just really cared a lot about learning about what's going on around me. So that was my science background, was like pure CS, optimization, architecture, stuff like that.
And then Stephen, Gabriel, what were you guys doing previous to Gaia?
So I have a degree in astrophysics. During school, I did a lot of research on number theory, mathematics, visualizing integer sequences. But most of my coding experience and skill set is in image processing and optical spectroscopy using telescope data. It was mostly focused on white dwarf research, so imaging stars that people guessed were white dwarfs, but we weren't sure. So, I take spectra of it, analyze, and confirm whether or not it is a white dwarf, and then, say some metrics about, what's the composition, what's the temperature. And I think a lot of that skill set transfers pretty well to any sort of geospatial remote imaging task, because you're dealing with images as well. And a lot of the transformations and operations and data handling is very similar.
Yeah. I have a degree in geography and with a minor in GIS, so I come from that world of geosciences. But before I came on and started working at Nickel 5, I was in academia for 4 years and working in space-related research. And I was building software and working on machine learning models for big NASA missions that are upcoming. And I was able to go to, big conferences and share research with the broader community. So, that's kind of when I jumped onto this. I think my contributions for space weather and, what those effects are on Earth, I came very prepared just from those 4 years of working on, big heady missions and stuff. So I would like to add, though, that Stephen and I, we've come to learn that both of our degrees have a lot of overlap. So that's why one of us can talk about a task and vice versa. Yes, we are specialized in each of the two tasks we have, but I do think there's a lot of crossover knowledge there just based on our scientific background, right? You'd agree.
Yeah, I agree.
Yeah.
Bringing all this experience and knowledge together, what are you guys doing with Gaia? What does Gaia do specifically?
Yeah. Okay. So right now, Gaia.
Break it down.
Yeah. Gaia is the bones of what is a much grander and more ambitious vision with a ton of technical challenges that we're going to have to solve along the way. But right now, our outputs are already useful to the research community. And the grand vision of Gaia is basically, there's so many different types of models in the geospatial field, and they're all very one purpose type of model. Like there might be a model for modeling soil moisture or the DST, or they're all so specific. They all take very specific data pipelines, and they're only really immediately useful in academia, if taken out of the grander context. So there are industries that use modeling and it has an immediate business impact. I would say insurance is probably like one of the biggest ones, calling into what's happening in LA right now, for instance. I don't know if you guys saw the State Farm canceled a bunch of policies last year, and it was an economic decision because they weren't able to raise their premiums enough to cover the risk. And they did that exactly where these fires just, destroyed. So actuarial science has a lot of risk modeling based on kind of what we're doing. Like they probably have soil and moisture models that inform their process there. So the grand vision of Gaia, getting back to that, is that we have so many potential paths of value in geospatial data, and all of this data is publicly accessible. It's or most of it is, and we collect the data. We have petabytes of it. It's all over the world. It's just that, what do we do with it, right? Like, there are companies that have their own teams internally that are maybe doing something very specific to their business with this data, but there isn't necessarily a go-to place where you can just not only see the data, but like use models to analyze it to get better outputs. So the grand vision is that we have a platform where we have many, many, many models and tasks, and they are somewhat interchangeable, but they can also inform each other. And how I got the inspiration for that was basically like mixture of experts architecture in large language models. If you have a bunch of layers or smaller, chunks of the model that are tuned to be an expert on a specific task, and then you have a gating network that basically, decides which experts to call on in order to answer a question. And this is really hard in geospatial data, to just build a mixture of experts geospatial foundational model, because it's like so many different kinds of models. It's vision, it's statistical. There might be a language component in some cases, but most of it is just like processing vast amounts of raw data. So the idea behind Gaia is to decouple the gating network from the expert models for now, and just focus on the expert models. So we want to incentivize, and we'll talk about the bounty system later, but we want to incentivize the creation of more tasks and more models for specific use cases, and also demonstrate how they can chain into each other. So we might have the soil moisture model it's lightweight. It takes a second to run on a laptop, and that can produce an output that could then inform a flooding risk model or something a little more complex. So the idea is that if we have all of these like purpose-built small expert models, and we have defined pipelines through those models, then we can produce actionable outputs now. And then the ambitious part of it is the gating network is figuring out, how do you really splinter and decentralize a model, so that when a user goes to the website and says, they could just like, it's like a chat bot or whatever, they just ask a question, and then the gating network and maybe it's an agentic large language model that's part of it, decides which data it needs to pull from which model and how to chain them together in order to best answer that question. So that's the grand vision, is like, we're creating tools for an agent, or we're creating these small components that we then hope we can link together in such a way that it becomes like a foundational geospatial model that helps anybody, any business, any government, like generate and use data that we already have. Like we have so much of it. It's just how do you use it to improve your business or to improve your city planning, anything. I mean, we all live in the world. We all want to understand what's happening around us. So in order to, do that in a way which is accessible, we need to take academic research and like all of these small little models and figure out how we can piece them together into something that becomes valuable. And so like it's a huge challenge to get to that end vision. But as we've all seen, like large language models are developing so quickly, and agents are all the rage now. Retrieval systems are being used in Fortune 500 companies already. So if we can build the tools for such a system, like we can create a platform for just understanding the world. And also, like, we all care about the climate. Like we're a little worried about our home. So if we can figure out answers to those giant existential questions along the way, like, that's really what I care about. And like, obviously it's like, we're trying to start a business, we're trying to commoditize something, provide value for people immediately. And then we have this like giant cloud of climate change and pollution and whatever hanging over our heads. And there's a lot of value in solving that, but nobody's figured out how to capture it yet. So.
And the current pieces to this grand vision is soil moisture prediction and geomagnetic prediction. Yeah. Can you explain, or I guess Stephen or Gabriel, can you guys explain what you guys are doing there, what the miners' tasks are? Is it collecting the data? Is it making predictions on data you give them? How does that look like?
Right. So I'll speak on the soil task. So in a nutshell, miners are, the validator tasks miners with predicting what is the soil moisture value at the surface level and at the root zone level, roughly a meter under the soil. How moist is the soil in this specific region 3 hours from now? So to boil it down, the way it works is that the validator will select several regions. We have a mapping internally to filter out any urban areas, any water masses like large rivers or lakes. Soil moisture values don't really make sense in those places. So the validator will pull data for certain regions. They'll pass it to the miner, and that data comprises like optical images from Sentinel satellites, vegetation index, elevation data, and then a bunch of weather data that's pulled from weather forecasts from the European Center for Weather Forecasting. Some of those parameters are computed, but the miner will take those into a model and return an image that looks ideally identical to what the ground truth soil moisture value is. In terms of scoring, we're using SMAP, which is soil moisture active passive. It's a satellite NASA runs. It uses microwave to analyze the ground and give informed predictions on what soil moisture is. And the reason we opted for that rather than like ground sensors is to get global coverage, because I think that is much more important and is much more accessible to do, since in situ sensors on the ground don't truly have global coverage, and there's some legal or political or economic boundaries to getting some of that data. Then Gabby, if you want to speak on the DST.
Yeah. So the geomagnetic DST disturbance time index. I wanted to put together, this is definitely more of where my passions lie, but space weather I think is super important. So validators are sending miners just hourly DST index values, and the miner is asked to predict what that next hour value is going to be. The scoring is pretty straightforward on those values. But yeah, I think for now it is definitely a little bit straightforward for miners to contribute to this, but hopefully adding on hours, predictions of in 2 hours or 3 hours, all the way up to 6, because right now the state of the art, like DST, is a 6-hour prediction window. So the goal is to get miners to contribute and perform up to a 6-hour prediction. But
Do you
yeah,
guys maybe want to both just share a little bit about why those two tasks are important, like what they can be used for now? I
Yeah,
feel
that's a
like
great
that's a
question.
good
Why
story.
is it important?
Yeah.
Who
Right.
cares about this? What
Yeah.
what impact does this have?
Yeah.
Why should
Right.
people care?
Yeah, I can answer that. So, like, when you ask why should people care about predicting soil moisture or DST, I think the reason we started with these two tasks is for several reasons. One, I think the data, the predictions and data those tasks in themselves generate is already valuable for research, in the sense that DST is very important for monitoring solar weather, and especially if there's like a coronal mass ejection or elevated solar winds, that can directly impact GPS satellites, sensitive electronic equipment on the ground, and the world is only being more reliant on that kind of technology. So I think that sets us up to eventually build a framework where we can make a warning system or a classification system that can help signal alarms in advance to say, hey, maybe you should prepare because there's going to be increased solar wind that might impact your satellites or impact the electrical grid. For soil moisture, I think the values in themselves are useful in research, but both of the tasks data lets us go into many different directions in terms of, like, we could either go the more agricultural route, we can go more disaster risk route in terms of predicting floods, predicting landslides. So I think it was smart to pick those tasks because it doesn't funnel us into one direction. We can kind of open up to a lot of directions.
Yeah, we see those both as good backbone for working on our proof of concept of chaining tasks together. So soil moisture has the agricultural implications, obviously, like carbon content and drought and all that, but then also like wildfire risk management. So there are teams of actuaries that do this for insurance companies, and it's all a very internal thing. And the regulatory capture in that industry is pretty huge. It's not easy to just say, hey, we have this product that, does it better than your team of actuaries. But that being said, it could be a product that they would want to use. So, like their internal teams. So that's kind of the direction we're heading with risk. And then same thing with DST index. Like there are already disaster warning systems for this specific thing. It's like this crazy exponent or like existential risk. If we get a giant, Carrington level event, it could fry so much of our infrastructure. Like it would be really bad. So at least having some warning would be nice. Although it's like if the entire internet goes down and it's all short circuited, it's not just like, oh, like we can fire it back up. It's like a lot of this equipment actually got broken. So you can imagine the chaos that would cause. So just having some level of better warning, we think like starting with DST is a good place to work towards a system like that. And then soil moisture can be taken in a lot of different directions. So that's why we started with those 2 tasks, but there are many more to follow.
And your primary consumers of these outputs that you guys create, you would view as insurance companies primarily because they're already doing this work internally and they could outsource that work to you guys. Is that how you view that?
That would be one path to revenue, yes, for the risk side of things. But it's hard to think of an industry that doesn't use geospatial data in some way or another. And our grand vision is like, let's make this a platform, because we can't do all this work, the 3 of us. Like we can do the skeleton of it, and we can introduce people to the idea and create some task pipelines. But if we want to reach our grand vision, we have to like tap into the power that is Bittensor and decentralized development. So, and that kind of leads into our bounty system. But we want to make it so that it's easy to bring an idea to the subnet, to the platform, and then contribute to the outputs. So if someone has a background in insurance, for instance, and they're like, oh yeah, I've been doing risk modeling for wildfires for 20 years, and this is the model that we use. Like, we want that person to come and put that pipeline on Gaia, and we're working on like if it's going to be a royalty, one-time payment. Still working out the details on that, but we want people to be incentivized to contribute like pipelines to this platform.
And then I guess that leads me to, are your miners like essentially black boxed and they just give you the prediction outputs, or do you have a way to where they are forced to open source whatever prediction model they've created?
That's a great question.
So I'm going to take a jab at this.
Sure.
But no, it's not a black box. I think miners, we have from the get-go since release strongly encouraged miners to build on our base models that we have for both of our tasks. So we have always encouraged miners to, whether it's simply altering the, hyperparameters of our base models, or using our like custom model, code that we built in. We really encourage that collaboration, and we want miners to do that, because that makes all of the predictions better and for there to be more robust data.
I want to add to that. Grant, I think you might have asked that question because I mentioned a similar, or maybe not, I don't know. Like last time we chatted.
Yeah.
But so obviously this is a problem in Bittensor, right? Like if a miner creates a really good model and no one else has access to it, they just get to stay at the top of the leaderboard, and like the end result is you don't have a lot of progress being made. And so like the subnet code is open source, and Bittensor's code is open source. Steven dropped out. He'll be back. His internet comes and goes sometimes.
Yeah.
Anyway, what I was saying is we do want those models to be open sourced too. And we're going to have a system that it's going to be a tricky challenge to build this. But basically, we need a way to still reward improvement. So miners that make a new, better model, like they get the reward for that. But at a certain point, we don't want them just sitting at the top forever and stagnating. And obviously, there's probably like an upper bound for improvement on a lot of these models. We're already pretty close to academic benchmarks on soil moisture. And it's like, how much further can you go once you're within 5% error on a future prediction? Like, you can't, predict the future with 100% accuracy. So there is an upper bound, but for the tasks that we like pay a bounty for in the future, obviously those will require a base model to be open sourced. But then we're also going to have a system that essentially gives a miner like a grace period. So if they create some new model that's like awesome, they get to ride those coattails for a little while, but at a certain point, they must open source it. So technically speaking, that's going to be a hard challenge. Like, how do you prove that the model they're running is the one they say they're running? Stephen and I have talked about this a lot, like proof of inference. That in itself is probably a multi-billion-dollar question. It's how, I mean, it's like, I could go very deep on this rabbit hole, and I won't, but we have thought of some ways that we can at least, like encourage that people continue to post the best model, and then people work from that model, so that as a whole, we're pushing the system forward. Obviously being in crypto, it's hard because people are greedy, and like, everybody's greedy, and we're fighting against a lot of forces. So that comes down to like designing an incentive system that rewards the people who want to be greedy, but also forces them to contribute to the open source movement of going forward. So great question.
And then you touched on this a little bit. You said you guys plan to expand to other things besides soil moisture and geomagnetic stuff. What other things are you guys considering adding?
Stephen, you want to talk about some of your ideas?
Yes, yeah. So I have a bunch of ideas, and I think tasks relating or similar to all of them will show up at Gaia at some point. That is my hope. One of the first ones I was thinking of was a atmospheric / cloud burst prediction model. And what inspired me to do that is there's a data set called the Well that Polymathic AI just released, that has several terabytes of physics simulations. And I think that would enable me to make a physics-informed base model that understands things like shear flow, which would be fluids, moving opposite directions over some sort of surface, like the surface of the Earth, and the fluid being the atmosphere, convection, turbulent flow simulations. If a model can understand all of those, and you can pass it in, pressure, wind direction, moisture content of the air, it is very likely that a model could perform well in predicting, where will clouds form, how big will the clouds be, what's the chance of precipitation. And, the reason I want to do that is, that combined with the soil moisture task can inform and get us closer to a flood or a landslide risk assessment kind of pipeline, in the sense that, if the soil moisture predicts that the soil is saturated, it's completely full of moisture, then the cloud model predicts, oh, there's going to be clouds and precipitation, then there's a higher risk of landslides because all the water from the rain falls into the soil, which is already saturated, so there's going to be a lot of runoff. So something like that, I think, would be really cool to do. On the other hand, I think some sort of carbon emission modeling is very important. It would look at, there's several satellites that do this, but it would look at data over urban centers, track CO2 emission. It may be informed by wind or other atmospheric elements as well. It can track, where will the pocket of carbon dioxide move to? How will it spread? And that kind of model could open us up to, some sort of model that understands urban impact on the climate, which I think is very important. Or it could open us up to some sort of model that could recommend ways, like recommend to governments or companies or cities, like ways to do carbon sequestration, like how much possible impact can you have in doing reforestation or doing pollution cleanup, etc. And then Gabby, I think if you want to talk about anything DST solar related.
Yeah. Steve and I kind of talked about in Aurora forecasting is something you can build off of geomagnetic DST indexes. And we all want to know where the Aurora Borealis is going to be because that's fun to go see. But on like a science level, that's where geomagnetic storms are affecting, the ionosphere. And we have seen in our lifetime these Aurora Borealises are coming further and further, like closer to the equator, when typically in the past they stay towards the poles. And a reason for that, is potential in our atmosphere thinning. There's pollution in our atmosphere, which, we could build off of what, Stephen's task has started and built off of. So there's a lot of ways to incorporate, just a simple Aurora forecasting task into something broader, like how thin is our atmosphere or what is going on in the ionosphere? Are there holes in our atmosphere and where are they? What are the effects of pollution on the atmosphere? So, yeah, there's a lot of routes we could go.
Yeah, I think I'll just wrap that up by saying like we do a lot of brainstorming on next tasks, and our precursors for picking a task are, does it fit into the current task that we have? Like, can we use the output from one of our existing tasks as an input, or as can we put them side by side? And our goal is to create a pipeline, one, to start, that demonstrates our vision, and then we can expand to other pipelines. But we want to, we're working with or trying to work with other startups, and potentially like present some of our current research. And we'd like to find a company that needs this sort of data, or maybe they don't even know they need it yet, but they could use it. And we essentially just want to, like, the first one, we want to provide it to them for free. We're like trying to find a company that's like, okay, they're doing something really cool in agriculture or or risk modeling, and we want to come to them and be like, look, these are the resources that we have. This is what we can offer you. We can build this pipeline and just give you this data for free to just demonstrate that we are producing something valuable to somebody. And I don't think we're very far off on that, but that's the hardest part of any business, is how do you take new tech and new research and turn it into value for a current business. So that is what we're working on now, is we want tasks that can take this data and then be valuable to somebody, even if it saves them, a couple $1,000 a year. Like, that's value. So
In terms of practical use cases for these things you want to add, Stephen, with the atmosphere and it working with the soil moisture, the ability to, predict natural disaster type events, to be able to give warnings to evacuate an area ahead of time, or with getting into carbon and carbon credits and the expanding market there. Is that how you guys see your customer base being in terms of practical use cases, applications, consumers of y'all's outputs?
Yeah, I would think that's a big portion of it. I think in terms of like disaster risk systems, like, things like that already exist. Like the government and the National Forest Service already have models that predict pretty well where forest fires will happen, how they'll spread, etc. A lot of those, though, are behind institutional paywalls. So I think a big portion of the value we can provide is giving the average person tools to understand disasters that will impact them in their area. Like, for example, someone that moves, to a certain place, close to the equator and close to the coastline, where they see a lot of precipitation in wet seasons, they might, before they move, or if they go to visit there for a holiday, or they hear that a monsoon is coming, they might want to have a tool to understand, like, am I going to be at risk for flooding or for landslides? And I think something like that's open source and is easy to use would be very important. And going back to like the LA fires we see right now, I think there's a big gap in wildfire modeling that has a hard time predicting how dust and smoke will travel. Because besides just the fire itself and the heat being the hazard, it does impact air quality a lot. And oftentimes, like, local agencies and governments have a hard time, figuring out which streets and roads to close because they don't have a good idea about how the smoke will travel. And I think that's something that, people living in the local area would love to be able to understand better. If we can provide some sort of atmospheric model, combined with the soil and maybe some other sort of fire model, if we can provide them pretty accurate predictions on, hey, the smoke is probably going to travel this way, you might want to keep that in mind and try to avoid the area and be safer. Like, I think something like that would be absolutely valuable.
Yeah. I want to touch on all that and just say that a lot of these existing systems that do this kind of modeling, whether it's weather or fire risk or anything, these are like old legacy systems built with like pure statistics and Excel, in a lot of cases. So it's obviously for weather, it's a little more complicated than that. But I would say a great example of that is the weather models that the National Weather Service uses. They're huge. They take a really long time to run on a supercomputer, and they're not even that good. So Google DeepMind just came out with GraphCast not too long ago, a couple years. And it's some weather services or weather stations are starting to use it in conjunction with these other models. And it has so far proven to be more effective in a lot of cases, more accurate. And it also basically can run on anyone's laptop as long as it has a decent amount of RAM. So it's pretty incredible, the power of machine learning advancement. And where we're at now is we have the potential to improve all of this modeling so much. And all of these industries are doing this, I'm sure, internally. But there's also so much advancement to be made. And in an open source format, it's just all out there for anyone to see. So if someone's interested in it, it has value to them. But also, if one of our miners comes up with a way better way of modeling fire risk, that's valuable to not only the people living in those areas, but to the insurance companies too. And I think in terms of insurance specifically, the messaging is really confusing for a lot of people. They're just oh, why did my premiums go up? Or why am I getting dropped? Everyone's complaining in Florida or because of the hurricane risk, or in LA, they're getting dropped by their insurance. And they don't necessarily have the messaging to know that, oh, this is a very high probability event that there will be a massive wildfire that rips through this community and destroys it. And that's the insurance industry's job, is modeling those things and then deciding how much it costs to offset the potential of that happening. And obviously there's a lot of regulatory complexity too. But the base models can always be improved. So that's, I think, where we're going to find a lot of value with Gaia is let's apply the cutting edge stuff to these industries that are still operating with a lot of legacy technology.
Who do you guys view as Gaia's primary competitors, whether that be centralized or in the decentralized science community? Who is the main source of competition for you guys currently? Or who do you look towards that's doing something similar?
That's a tricky question, because I don't think, especially in Bittensor, there's nobody doing this. And then in the broader scope, I would say our primary competitors are like defense companies or insurance companies. So like Lockheed does a lot of risk modeling and has products that do that. And through my brief internship with them, I learned that their systems are very much, based on legacy technology and like are in some ways stagnated. So I think that there's a ton of opportunity to reach out to, I mean, obviously we're not going to go get a contract from the government right now. Like we're a team of 10 people total, and we're not competing with Lockheed directly. But the thing is, like, there are so many levels to it where, like, yeah, we're not going to get the US government to say, oh, hey, Gaia built this risk warning system that's better than Lockheed's. It's possible that we could, but like, I think our core idea is like, let's start small and like, with agriculture, for instance, that like you have a bunch of small farms, right? And the number of those are shrinking. Like most of farming in the US is now these giant agribusinesses that are conglomerates. And that's the only way to really be profitable unless you're doing farmers markets. And there's such a massive like gap in resources between, a giant agribusiness and a small family farm. And I think if we can provide a data product to those small family farms, like that helps them compete with these giant farms that have drones flying over doing infrared mapping, and they know exactly where their soil is degrading, and they know exactly how much or how little nutrients to put into 1 square foot of their field. Like if we can offer that as a service to smaller businesses first, like we can then like, help them close the gap, provide value for them. But then we also get to, develop a product that might compete with the larger companies at some point. So
In terms of competing with these larger companies, are there any specific benchmarks that you judge your success against that's a universal standard? Or do you judge y'all's progress based off your ability to serve those smaller players and clients first, prove success there, and then work your way up the chain that way? How do you guys approach it?
I think benchmarking is tricky in a lot of these cases. We have academic benchmarks for days, and that's easy. But what we don't have is like an intimate knowledge of State Farm's modeling department. That's like, intellectual property for them. They're not going to open source how they do things. So there is a gap there, but I think the gap can be filled by targeting smaller businesses for a long time. And then at a certain point, like we may surpass, and even if it's open source, but like at least we are then creating something that makes everything more efficient. My hope is that we open source it, but that we create such a good pipeline for accessing this product that instead of people just taking the open source idea and rebuilding it for their own profit, that they are like, well, why don't we just use this? It's already set up. They already have APIs. They already have a user dashboard. It's a quarter of the price of going with this other guy. And then with a DTAO world, that money would just kind of flow back into the system. So I think DTAO, decentralized organizations, they're all like exciting crypto buzzwords and haven't really manifested in something super real yet. But I do think that the potential for like incentivizing this kind of collaboration and then rewarding the right people for collaborating is super powerful. So it's it's a whole new paradigm, I think. And like to compete with a giant multinational corporation, I mean, Bittensor, that's kind of like their whole thing is like, oh, like open source. Let's be real. We don't have Bittensor's market cap is 3 billion. OpenAI builds $100 billion data centers. So like the compute is crazy, but there is a lot of progress to be made in the smaller areas and like making AI ML accessible to everybody. So I think that's where we want to start our focus.
And then in terms of these academic benchmarks, how are you guys currently stacking up against them?
I'll
Steven?
speak for the soil task.
But you're on mute.
I'll speak for the soil task. So what I've done is I've sort of averaged all the benchmark numbers, because a lot of research papers are focused on specific regions or specific climates. There's not many that do global coverage models like what we're trying to do with the soil task. But I've defined 3 lines which are informed from actual research papers. We have like a poor threshold, a good threshold, an excellent threshold. So we're measuring root mean squared error, just literally, what's the size difference between our moisture value between 0 and 1 compared to the ground truth. Currently, the base models, which, we'd assume and would like to be the worst performing, ideally miners, exceed that.
Yeah.
In specific regions, especially drier, warmer climates, our model actually outperforms a lot of research models that do try to do this sort of general global coverage. In other regions, which were much more difficult to predict, especially like colder, wet environments specifically, we are below the benchmark. But in general, our model performs equally, if not better, on average, compared to globally informed models. We aren't as competitive compared to region-specific models, but that is to be expected because those models are developed and tuned for like, a specific region of India, for example. So their architecture will have specific attention heads and physics-informed layers that understand the dynamics and specifics of that climate. So I think our base model trades off accuracy for generalization across the board, which I think was the smart choice because that allows a much more flexible base model for miners to then extend and include all of those, climate-specific, physics-informed layers, which is, when if you'd ask, like, what could miners do to get us closer to the benchmark, that would be it. It would be, including climate-informed attention heads and decision-making that, understands, this part of the world has this kind of dynamics versus this part of the world has different dynamics.
Yeah. And for the, geomagnetic DST base model, I built that base model to reach, over it's 85% as accurate as the state of the art, so I built that intentionally to be right there below the soda. So that way, when miners come in, if they're just using the base model, they're still contributing to the overall success of the prediction. But it also is a magnificent base model for miners to come in and simply like change and alter and tune hyperparameters. And we've already started seeing a lot of miners take action and all are like building their own DST based models, which are outperforming the SOTA currently. So it's definitely happening, and we have those academic benchmarks for both tasks. I would like to boast on, Steven's soil model. It's pretty magnificent in itself on a global scale. But yeah, it's cool to see that miners are already taking initiative and trying to get closer to that prediction, for sure.
Yeah, I would just reiterate that, like, we basically launched, 3 weeks ago? and we're already seeing, I think the DST model was like a time series model, so relatively simple to expand, and there's so many ways you could go with it. The soil moisture model, we expected it to take quite a bit longer for people to start improving that because it's a lot more complicated. But we're already like pretty close to benchmarks, and in some cases exceeding them, and we're seeing improvement from miners. We'll have a dashboard up soon that kind of like will give a better idea of where we're at right now, on average. But yeah, we're close to benchmarks already, and we expect to see that they are exceeded. I think that an incentive system is powerful. A lot of these models are inspired by research that, you know, it wasn't exactly incentivized. Like maybe it was someone's pet project or PhD thesis, or it's their area of focus. But I think that the power of the incentive system cannot be denied. I mean, just looking at Next Place, our real estate subnet, we don't work on that, but we were all shocked to see how fast that miners met and exceeded the Zillow benchmark. It was within 2 weeks. So we think that the benchmarks are going to be exceeded pretty quickly.
And you would only have to assume if the subnet incentive rises, the faster the pace of innovation.
Exactly. I mean, we are still at a point where it's quite low incentive. It's not zero anymore.
Yeah,
which is
last I checked, it was 0.04% in terms of incentive. So just to be close to benchmarks,
bringing in about $300 a day in owner emissions. So, not really covering our salaries quite yet, but that's all right. We think that once enough people, like once the messaging is more clear, once we're a little more rooted, that people will see the value in it pretty quickly. And it's also just it's a really interesting field. I mean, we have miners in our Discord channels that are like, oh, I'm a geophysicist or a geologist. This is like what I've been waiting for in Bittensor, because this is the kind of thing I want to work on. And so I think that us offering that is also just exciting for certain people. We all have our own opinions on LLMs, and we think that while they're very powerful and interesting, they are over focused on Bittensor. Like pretty much everyone is doing an LLM thing of one kind or another, or maybe vision, but then the vision ones are just, like trying to, I don't know, they're not even Mid-Journey competitors, So I think like offering a different platform for different machine learning research. I mean, it's an endless world. You can pretty much do anything with machine learning as long as you have data. So it's cool that we have this on Bittensor now, and we're happy that we haven't been deregistered. So we'll see what happens with DTAO. That should be interesting.
Yeah, your subnet definitely brings new ideas to Bittensor. In terms of decentralized science, I would categorize it as you guys and protein folding currently as the landscape.
Yeah.
But I'll wrap it up with this. It's a question for each of you.
Oh,
Sorry, I do want to add like one thing that we haven't really touched on. In terms of academic benchmarks and, it being competitive and who are competitors, I would like to say, like, in the realm of Bittensor, we are, I think, going to be the first subnet that brings our data to an academic research conference. Not other subnets in the community are not trying to strive to be part of the scientific world. And I think that's what sets us apart. And maybe we're competing with one other subnet or within the community, but it's like we're also competing in a way that we're bringing a decentralized network's data to a broader scientific community, and to share that, hey, you don't have to have a PhD, to do cutting edge scientific research. You can build a community and bring really important data to the world.
Yeah, I
And
wouldn't even say
yeah,
have competition within Bittensor besides maybe just competing for the interest of validators who will weight us. But I think like, it's possible that someone else starts a geospatial subnet, and I would encourage that. I think Bittensor itself, it's almost like an incubator of sorts, and I don't think that viewing. I mean, I could talk about competition with Bittensor, but I don't think that in this case I'm even really worried about a competition within Bittensor. I think it's like it should be a collaborative thing, and if we're like, trying to move advanced science, like that's not necessarily like a cutthroat type of thing where it's like I do better science than you, so I should get paid more. I think if we can keep it open source, we're all like benefiting from it eventually. So I think Gaia, it's almost like we don't have competitors on Bittensor, and maybe we will, but I'm not too worried about it.
Well, I'll wrap it up with this one.
Yeah.
For each of you guys, what is your ultimate goal, your ultimate vision for Gaia, for its technology? What do you envision it being? What do you hope it achieves? What's the end game for Gaia? In each of y'all's own perspective.
I guess,
Steven, you want to start?
I can start answering that. So I think in the grandest of visions, Gaia is a platform and a tool that accelerates environmental research. And what I mean by that is, to me, it reminds me a lot of how the astronomy field often functions, in that there's so much data out there that's easily accessible, and so much of it that like specific research groups and companies just can't parse through it all. So often or not, like amateur astronomers do make meaningful contributions and meaningful discoveries. And I think the same thing is possible and happens here with geospatial data. I think if we can develop a platform and tools where the average amateur enthusiast or researcher that doesn't have access to a ton of funding can use the tools and data and analysis pipelines that we provide and can contribute to understanding how climate change impacts the world, then I think that is a net positive on the world. And I think, climate research in general is super important because, we all live on this planet. This is the only planet we know of that has life on it. And I think, understanding what impacts to, the food chain and to, our future life would be, and being able to predict that in advance to then inform, how should we best handle that? I think that is really my grand vision.
Yeah, and I totally agree with everything Steven just said. But my kind of grand scheme is, it's from my own experience of moving to where I live now. 6 years ago, I had to do research on the internet for each question I had. And it's like, I would have loved it if I could go somewhere and say, hey, tell me the climate, tell me the hazards, tell me what's up with this place I'm going to be living at. Because I am a weirdo who bases where I live on the safety of natural disasters and spatial things. I don't want to live in a tsunami zone. But I think having a tool for anyone and everyone to access would definitely be my broader vision. Even if it's one person who gets to utilize it, I think that's making a difference.
Nice. Yeah, I would echo both of those. I think that since I was as young as I could remember, climate change always really bothered me. I remember being like 8 years old and being like, the polar bears are losing their ice. Like, shit. bad thing. And now, I did a lot of climate research in school, and we face crazy threats. Like as humanity, we face an existential level threat from climate change and pollution, and it's easy to be like alarmist about it, but it's also easy to be like, well, things happen slowly, we adapt, we'll be fine. But in that space between, there is trillions of dollars and billions of lives on the line for what we're facing over our lifetimes, the next 50 years. And I can't remember who said it, but people have said, there's so much money in solving these problems. It's just that it's very hard to capture because it's all like negative externalities. Like, if you regulate carbon emission here, the companies just move here. And like, it's hard to coordinate global action. And really, we need almost like an economic solution, something that profits somebody, unfortunately. So I think for my entire like career, I want to work in this area of like, how do we bring solutions to these insane problems that we face as humanity while also helping somebody profit along the way, because that's the only thing that drives innovation, is somebody's got to make money off of it. So once we can accept that, even if it's sort of frustrating sometimes, I think there's a lot of ground to be gained by tackling that problem. And I think that making it a platform, making it collaborative, allows for the idea to grow and people to contribute their own expertise and knowledge in specific areas. Like, nobody can claim to know the best way forward for any specific industry. But if we create this like place where people can come together and work on these problems, and it's like modular, then we're growing something that's much greater than ourselves. And that's my grand story about the inspiration behind Gaia.
Noah, Gabriel, Steven, it's been a good time talking with you guys. Thank you.
Thank you,
Thank you
Grant.
so much.
Thank
Great
you.
you.